Okay. A very good morning and a warm welcome to every one of you present over here. Society for the Advancement of Agricultural, Horticultural and Allied Sciences SAHAS welcomes you to the fifth day of training program on precision farming. In the course of present century, where the world population has increased from 2000 million to 5000 million, demand has been placed on food production system that again depends upon soil and water resource. In light of this, it becomes imperative for the development and implementation of more productive and sustainable management system. So let us cherish the earth and make the world a better place. With immense pleasure, I'm here with an introduction of one commendable personality who has a profile full of successful academic endeavors. I'm talking about Dr. Arun Alfred David. Bringing into limelight his accomplishments, he has been specialized in the field of soil science, soil fertility, and integrated nutrient management, and have been presented talks on All India Radio and television. Back in the year 2005 to 2006, he has been worked as the program officer of National Service Scheme in Allahabad Agricultural University. He has also served as associate editor in the editorial board of International Journal of Agricultural and Allied Sciences since 2015. Being an executive board member, thrice he has contributed about 50 chapters in various books. He has published about 40 popular articles and have been a part of about 10 training programs. Considering his outstanding contribution in the field of soil science, he has been conferred with Excellence in the Teaching Award. He has also been a member of advisory board of All India Agricultural Students Association. He has been an advisor and supervised about 105 MSc students and 7 PhD students. So currently serving as an associate professor, Department of Soil Science and Agricultural Chemistry, Pragyaraj, Uttar Pradesh, India. It's our honor to have with us Dr. Arun Alfred David today. Now, I call upon Dr. Arun Alfred David to deliver a brief talk on soil fertility and nutrient management for sustainable agriculture in India. Over to you, sir.
Thank you. Today, my topic will be on soil fertility and nutrient management for sustainable agriculture. First of all, I would like to thank each and everyone for the Onam festival, as well as very good morning to all. So, this soil fertility and nutrient management, as you can see, for sustainable agriculture is very, very important for our country. Why? Because our growth rate of population is increasing day by day. It is near about 1.68 billion we are going to reach in 2050. This will increase in demand and food grains demand from 333 to 400 million tons of vegetable, fruits, animals. Then it increased the met of the fixed arable variables of 141 million hectares with less scope of further horizontal expansion, out of which 120 million hectares is estimated suffering from different forms of land degradation. Land degradation is a big problem in our country because every year, every day, the land degradation is increasing day by day in a large scale, and we are short of that. There are so many kind of land degradation, problematic soils. We talk about from the hills to say up to Kerala, all places we have this kind of problem. There are saline sodic soil problem, lead rhyolite problem, black cotton soil, many other calcareous soil, many. So we have to come over it because one of the department which is dealing here in our country and in our state, that is Bhumi Sudhar Nigam, that is there in Lucknow. So we have to consider that loss of land, nutrient, other things. Next, a large of the total population is 58 to 65% of our country depends on agriculture. It is near about, it is written though as 58 to 65, but it is 70%. So, for their principal means of livelihood, in spite that the share of agriculture in the national gross domestic production is only 18.3. This data comes from the, you can say, Ministry of Statistics and Program Implementation 2020. Agriculture in India. India is very well known for agriculture from the very long time, and we were the best for the natural resources. But now we have spoiled somehow the other a large portion of our land. So India needs very good management practices for agriculture. Near about 400 million tons food grain is required in the year 2050 against the current level of 252 million tons. So it is a huge gap. How we are going to come over it, how we are going to approach it. So there should be a good strategies we have to follow. And that has to be done by each and every one, from the grassroots level to upper bodies. At present, India has a food grain of 145 million metric tons against the total food production of 311 metric tons, leaving a gap of 166 million tons. Agriculture land in India have was reported 60.2% in 2020 according to the World Bank. India arable land area is 159.7 million hectares, and from 394.6 million acres in the second largest in the world. Here I would like to mention and quote about the slime soil in Uttar Pradesh. We have a big area which is spoiled, which is not arable for the crops, for our generation to come, and we are in a loss. We have to manage these soils in many areas like Sultanpur and near about nearby area Raebareli and so on. India had 718,000 hectares not available for cultivation in India is 12.34% of the total land. Consumption and demand of fertilizer. This has to be understood by each and every farmer, each and every one. We call ourselves the scientists. We have to know from grassroots level, and we have to communicate the things which is demanded for the farmers in their respective fields. So we have to go and talk about consumption and demand of fertilizer in India. We have spoiled many areas because they are following the old traditional method of cultivation of the crop, applying it what you call their traditional farming system, which has been given to them from father, grandfather. So they are following same pattern, which they apply just according to the bags. The total consumption of fertilizer product is 63.94 million metric ton during 21 to 22, showed a decline 5.4% of over 22.21. All India NPK use ratio went from 6.5 ratio 2.8 ratio 1 during 2021 to 7.7, 3.1 during 2022. Per hectare use of total nutrient reduced 160.1 kg in 2021 to 146.7 kg in 22. So we have to concentrate for the consumption and demand of fertilizer when they are required in a large scale to the farmers, to the people. They are not able to get the things in an appropriate time. And when the fertilizer is not given at good required stage for the crop, it is very difficult that plant can give maximum yield or enhance the yield. Requirement of total fertilizer nutrient is estimated to be around 60 million tons by 2050, as against the current nutrient consumption is 334 million tons. It is a huge gap. We can see it here. The Indian fertilizer market is expected to grow at CAGR of 4.7% between 2023 and 2028, reaching a projected value of USD 1,160.18 million by 2028. The Indian pesticide market was worth 181 million in 2017. The market is further projected 292.9 billion in 2023 at CAGR of 1.83 during 2018-23. Here we have a figure which gives trends in agronomic efficiency response. Grains per kg means NPK. So you can find out here the fertilizer nutrient, plant use efficiency, and nutrient loss. How much is taking place? In the year 1960-69, it was near about 4. And the year 1970-79, it was maximum 10, 11. Then in 1889, it was again it reduces. So on, it reduces a trend. We can see here several data has been reported. The fertilizer use efficiency and loss percentage. So it is a huge demand. Here is the rating chart, which we can talk about in terms of practicals, and you can go through all these things. These are some chemical parameters of the soil: organic carbon, available nitrogen, phosphorus, potassium, sulfur, and so on. The micronutrient: calcium, magnesium, zinc, manganese, iron, copper. So these are the rating chart which has been given. Indian soil traditionally have low nitrogen and phosphorus content and potassium as per as 2019-2020. Soil has survey has been reported. Government, 55% of the country's soil is deficient in nitrogen, 42% in phosphorus, and 44% of in organic carbon. So here the organic carbon shows a very huge this thing. One of the meeting I went in Lucknow, it was called from the Agriculture Directorate, and our Honorable Chief Minister has called that meeting. That what about organic carbon? Why it is going day by day? It is going down. So we have to think over it. We have to come for that. So integrated nutrient management is emphasized for this organic carbon percentage. When we talk about all this, we should know that when our independence was taken place in the 1947, and when the soil survey was taken in 1950, then what happened? It was zero point 0.8. Now it is 0.4. So we have come down. Very low status has been shown over here. We are doing the many of the experiment and so on, the things. So we can see the trend for organic carbon is going down and down. And organic carbon or organic matter play a vital role. It is a key component. It is a key this thing, for all this thing, elements and this thing, nutrients. They provide. They are the storehouse in soil to provide all these nutrient and element to the crop when it is required. So day by day, our soil is getting exhausted. Here it is given by Soil Health Card Nutrient Status, Union Agriculture Ministry, and India Data Portal. There is a ICR portal also. The data measures nutrient levels in number of samples from the state. The samples are charted here as a percentage of the total on the basis of the 5 categories, which you can see here. This is for Uttar Pradesh and one is for Haryana. So everything is given here. Very low, low, medium, high, very high. These are the rating charts. And when we get training, we should have a very good knowledge that is shared by the professor, the scientists, the trainers, all those who are associated in the programs. So we have to answer. This is soil test allotted in different state of India by Government of India 2023 through Soil Health Card Scheme. Soil Health Card Scheme was launched by our Honorable Prime Minister in the year 2015. So this thing is going on and he is also working, and these people are highlighting the things, and it is required for India. Next slide is nutrient status of India by Government of India. You can see nitrogen is there, phosphorus, potassium, organic carbon. Then, as we have talked about soil degradation, it is a huge problem everywhere. Whether you talk about any state, any region, we have this problem, soil degradation. And it is a huge problem. It is a great loss for the nation, for the people of India. So, as a scientist, agriculture scientist, we have to work very hard to give the maximum to the farmers so that they can do. Nothing can be done in sitting in a room and manipulating the data and giving to the people. We have to go. We have to demonstrate the experiments, the things to the farmer so that they can do. India is starting a major crisis. That is true. Healthy soil contains 3 major nutrients. Next. How to fix soil degradation? It depends upon the place to place. Manage this thing. We have to manage the things according in the village, blocks, and tehsil level, and we have to take the help so that we can approach in a nice way. Apply conservation tillage techniques, practice crop rotation, alternate crops using strip cropping, avoid over irrigation, apply the right amount of fertilizer. This is very, very important. Apply the right amount of fertilizer. Being a soil scientist, we have to go and tell to the farmers, and we have to come out with the appropriate and correct results to do it, so that farmer can apply the right amount of the nutrient or the fertilizer which plant, soil as well as crops require. Aim for organic farming, plant covers crops, adopt contour farming, practice terrace farming on the slopes. These are the states. State-wise consumption of chemical pesticide unit, metric ton. So these have been used year by year. These states, Andhra Pradesh, Bihar, Chhattisgarh, and it is given in many of the things, journals, magazines, and it is available in the portals. All India use of fertilizer products. We talk about urea, DAP, MOP, NPKS, and SSP. These are the 10. In the year 1960-69, cover yield response to the fertilizer, cover crop yield response to the fertilizer. Now we can see the crop yield response to the fertilizer. The things has been given here 12.1, 10.7, and 9.1 in the 80s and 89. And these data are very, very important so that we can categorize the things, what is happening day by day, and how we can come up. What is soil? See, soil is one of the, it is like mother to us. We have made by soil, one day we will go to the soil. But the people have come, the scientist has given their own distinct, definition of soil. But it is very, very important. Simply, it is a mother for each and everything, living, non-living. Soil is a complex mixture of minerals, organic matter, water, air. Very, very important. And living organism that covers the earth surface and provide a critical foundation for plant growth. It is a vital natural resources that sustain agriculture and support ecosystems. Soil plays a crucial role in feeding the nation by providing the necessary nutrients, water retention, and physical structure for crops to grow. However, the quality and quantity of the soil are increasingly threatened by the factors such as erosion, pollution, urbanization, and improper land management. This has been given by the Smith 2021. The scientist has quoted like this. But what is soil? I have told you it is nothing but it is a mother. What we have to do, at least one plant we should sow on the earth, and we have to nurture it like mother nurtures the baby so that it can grow well and bring good fruits like you people. So I think most of the majority of the students are there. I'm talking about in terms of their this thing, and this is a part of distinct chemical health, physical health, biological. Now everybody is focusing on soil health nowadays. Now one thing is that the soil is a major distinct, major in agriculture. Without soil, nothing can be done. Nothing can be done. Every sub branches are there when you talk about so agronomy, horticulture, plant pathology, anything. We start from soil because you can see when we go to the PUSA, IARI, New Delhi, when you enter, you will find in right hand side there is a department called soil science. They start their department from soil science, and many of the people are working over there. So these are the chemical health we have to take care. This is a physical. I will count from physical. Soil structures, soil texture, porosity, water retention, capacity, soil aeration, thermal regime, then chemical reaction, CC, cation exchange capacity, nutrient reserves. Next is elemental balance. See, these 4 points are very, very important, and it varies from place to place very frequently. And we don't have proper indexing inventories in our records for the farmers. Many of the program has been run, but they are not continuing. There are so many distinct factors are there, but when we talk about chemical health, we should take care. We have to go there and we have to analyze the things in a grouse root level. And awareness for the farmer is very, very important. Farmers should know the chemical health so that they can maintain the status for soil. And biological health, people are working for this. Many scientists are working and they are coming up with good results. Soil biodiversity, soil organic pools, microbial biomass. Next is soil fertility. I think here everybody knows about soil fertility. Soil fertility is a key factor for successful crop production, and it is measure of capacity of soil to supply plant nutrients. Soil fertility and fertilizer are very much closely related terms which are together. If the fertility is not good of the soil, we can't achieve the target which we require. And when we are not required any good distinct target or yield or product produced, so it is very difficult. Soil fertility acts as sink, wherein plants can draw nutrients from maximum yield, whereas fertilizer act as a source, wherein we can draw continuous different nutrient and also add it to the sink. Then we can see this soil plant nutrition, this diagram, feeding the soil, organic fertilizers, organic matter, soil nutrients, plant nutrients, microorganism, chemical fertilizer, plant nutrients. So it is very well known. If we maintain all these kind of distinct factors and the properties which we can see, we can have good response. History of soil, though it has been given from the so long time, Nicholas Theodore has given this in the 1804. A Swiss physicist and Jean-Baptiste Bouchard in 1834, a French chemist. Agriculturists were first to report that the plants need mineral nutrients for growth and development. So this has been noticed from a long time. And if we go through all these micronutrients, macronutrient, calcium, magnesium, and so on, we can see how it is required, where it is required. In terms of macronutrient, how much macronutrient is required, how much micronutrient is required, it is given. It is more than 100 ppm, and when we talk about micronutrient, it is less than 50 ppm. The importance. The impact of soil fertility are reflected in the most of the sustainable development they contain economic, social, and environmental aspects. These are very important. Economy is there from the beginning, and in every field, the economy has a very distinct, important factor. We count according to the per capita requirement. So, the main function provided by the fertile soil is provision of food, which is very important considering FAO zero hunger objective. Then a fertile soil also provides essential nutrients for plant growth to produce healthy food with all the necessary nutrients needed for human health. So this is, we can't neglect the things. Anyway, we have to be very cautious. What we required that we have to be very alert. Moreover, fertility has an impact on activity with economic impact and is therefore related to economic growth and fight against poverty. See, we can do good if we are our agriculture is good, the produce is, the quality is good, and we have the system so that we can go through. Uh, In India, it is having a great scope of agriculture in every field. Why? Because it is required. People require good food, sustainable food, and that can be achieved by the people. Those are involved. What can we do for improving soil fertility status? Farmer role is different, government role is different, our role is different, whether you call about the ICR, you call about the universities, agriculture universities, organizations, all this. Farmer can improve soil fertility and soil health by optimizing soil nutrient management. Government should promote sustainable agricultural practices, technology, and management. Here, a government can do in many things. They can subsidize the things. The product can be subsidized. Many things which they are using in farm tools, they can be subsidized. Latest technology should be given and provided. The International Code for Conduct of the Sustainable Use and Management of Fertilizer promotes practice include nutrient cycling and agronomic and land management to improve soil health. Land management is a very wide scope we have in land management, and we should know about the land management. Everywhere you can't sow wheat, everywhere you can't sow rice. Next is how to measure soil fertility status. These are the things which we have to consider uh, for maintaining soil fertility status. There are 4 critical steps to soil test, and which has been given. That is, number 1 is sampling, analysis, interpreting the results, recommendations. These 4 aspects are very, very important. If we are not able to take the sample in the field in a proper way, then the result may vary a lot. From the farmer's field, it comes to the lab, and from lab, it goes to a practical this thing analysis. And if there is some kind of contamination, then the result will vary. Lot it will vary. And analysis should be done in a very appropriate protocols we have to follow for analysis, whether we are using equipment, glassware, tools, what are the things like AAS, all these systems we have a knowledge, then only we can do. We should know the maintenance of all this, how to keep it, how to use it, and then interpreting the result. See, generally what we do, we take the sample and we bring it, and then we analyze and we just say the farmer that you have this much nitrogen, this much phosphorus, this much potassium, and go and do this way. So they adopt, but the things are very different. We have to give the appropriate interpreting results so that they can go through that in that way. And then comes the recommendations. The recommendation should be given from the root step to the part, so that they can get the good result, and then the recommendation they adopt, then only the cropping can be done. And then we can enhance the yield in farmer's field. Cause and consequences of decreased soil fertility. Declined soil fertility occurs when the amount of nutrient removed from the ground exceeds the amount added. Plants will then extract nutrient from ground reserves. Reserves are depleted until no more resources available for plants. Loss of soil fertility has a significant negative impact not only on agriculture production but also on the surrounding ecosystem. Here, the word which we can see the ecosystem is very, very important, and we have to maintain our environment, ecosystem, and things on village, block, and neighborhood values we have to keep so that the people can take the interest. We have to go through, as I have told, please plant a tree so that something can be done, something can be produced, some environment can be developed. Our forests, day by day, we are having less forests. How? Because in our state, Uttar Pradesh, maximum forest has gone to Uttarakhand. So everyone is facing the problems. Land depletion causes desertification, biodiversity loss, pollution of water bodies, and potentially dangerous changes in waterways. See, everywhere the contamination is there through many uh, point source, non-point source, and the things are coming to the soil, to the water, to the crops, and ultimately the livelihood and the human and livestock has to be suffered. The following are the primary causes of loss of soil fertility. The use of fertilizer without regard for the field conditions, unsuitable cropping system, continuous cultivation of crops, intensive tillage, monoculture cultivation, complete clearing of crop residues, soil erosion and land degradation. Soil erosion itself is a very, very big problem we have because there are types of soil erosion and many losses are there to the soil. The fertile soil goes it is taken by the water erosion is main of the cause of that. Uh, Wind erosion is there. Next is unfavorable climate and extreme weather condition. Everything we have in our country. How to improve soil fertility? There are very different ways to improve soil fertility. And we should, first of all, dear friends, we should have interest to maintain soil good health. Then only the productivity will come, then only the things can grow, then only the wellness can come to our country. Even fertile and land depletes over time. So fertility must not only be preserved but also improved. Suppose we talk about mineral soil. We say कि सब mineral soil has a four major distinct air, water, mineral matter, and organic matter. And how the soil becomes distinct, how much time it takes to become a particle of soil. It is we should know how in 1 kg of fertilizer, if we are using, how much grain we get. All these kind of things we should know. That is very difficult. 500 years to 5,000 years are taken to become a particle of good soil. And we require mineral soil. And if we don't have mineral soil, we have to convert it into mineral soil by all mean sources. So we have to apply all these three aspects when we talk about. So we have to go for all these kind of things: crop rotation, fertilization, mix planting, sowing green manures, crops mulching, and following following help in increase field fertility. The impact of living organism on farmland fertility is also hard to estimate. Earthworms, beneficial fungi, bacteria, protozoa, and cellular organisms are extremely helpful to the soil. Natural pest enemies such as birds that eat insects, larvae, or weeds, seeds also indirectly increases soil fertility. So next is nutrient management. It is a complex this work, this what we read, nutrient management. It changes very fast. It changes. So INM practices we have to use: integrated nutrient management, integrated nutrient management, plant nutrient management, and SSNM, site-specific nutrient management. This is very important because it varies the status of soil in all the parameters which we considered. The site-specific nutrient management is very important, as well as their inventories in the registers of district, whether you call it district or block level, tehsil level, village level. Anyway, we have to maintain our registers. Then comes STCR, soil test crop response. Then comes DRIS, diagnosis and recommendation integrated system. Then comes integrated plant nutrient management. It does embed soil nutrient, water crop, and vegetation management practices tailored to a particular cropping and farming system, undertaken with the aim of improving and sustaining soil fertility and land productivity, and reducing environmental degradation. Here, I would like to emphasize this: improving and sustaining soil fertility and land productivity and reducing environmental degradation. This is very, very key points which are of our distinct presentation: improving, sustaining soil fertility. Without awareness of the people, without awareness of the farmers, without the requirement, without the experiments, without the theories, we can't do it. We have to go to the field. We have to serve to the nation as well as to our field, our soil, mother. Goal of integrated and nutrient management: to ensure productivity and sustainable agriculture, to reduce expenditure, to utilize the potential benefits, to prevent degradation of the environment, to meet the socio-economic aspiration of the farmer without harming the natural resource base of agriculture, the principles underlying nutrient management. This is an important thing we should know, the principle, and everybody knows about the principle. Key component of integrated nutrient management: plant system analysis, plant and symptom analysis, tissue analysis, and soil testing. This I would like to emphasize that soil testing should be done in a very correct and proper way. And advantages, what is this? Uh, uh, then site-specific nutrient management. Everybody knows about, we have talked about Then comes history of site-specific nutrient management. Many of the scientists have been reported the example of key scientific principles and associated practices. Four are nutrients have been given by the stewardship, and these are the product, rate, time, places. They are the key component of this thing, scientific principle, associated practices of four requirement. Site-specific requirement, plant analysis based. Here is Asian countries propose 5 key steps for developing field-specific fertilizer and PK recommendations, selections of the yield goal, assessment of crop nutrient management, estimation of indigenous nutrient supplies, consumption of fertilizer, nutrient rate, dynamic adjustment of the nitrogen rate. These are the main features. We have to think over it, we have to know about it, and then we can go. Selection of the yield goal, we should know what kind of estimation of indigenous nutrients. So, yes, Sunil, and I think it is over, but a few quotations I will give. That is very important, and I think the time is up. So, I can conclude this.
Sir, no issue, sir. You can continue, sir.
Yes, within 2 minutes. Soil fertility and nutrient management are crucial
Hello,
for
sir. I'm audible.
sustainable agriculture in India. Uh,
Hello, sir. I'm audible.
yes, yes.
So you can
Hello?
continue the presentation. Yes, sir.
No, I just concluded it. I hope somebody is talking about, so I don't think the. Hello. Yes, I will take 5 minutes. 5 minutes. Soil fertility and nutrient management are crucial for sustainable agriculture in India, where the soils are derived and multiply nutrient deficient. Various technologies, programs, and policies have been implemented to improve nutrient use efficiencies and manure management in agriculture systems such as soil health cards, organic farming conservation, agriculture and biological nutrient resources. These, these practices aim to optimize plant nutrition, reduce cost of cultivation, enhance soil organic carbon. Recommendations are given by the big people. So I would like to go through it. Hello, something are wrong, I think.
No, sir, you can continue. You are done, sir.
Yes, I have done. I have completed, but something was missed. Should I go through it, or it is okay?
Yes, sir. You can go through that.
Okay. See, I will come very brief in this. We were talking about the various technology to improve the soil health. Programs as policies have been implemented to improve nutrient use efficiencies and manure management in agriculture systems, such as soil health cards, integrated nutrient supply system, micro irrigation, composting, organic farming, conservation agriculture, and biological nutrient sources. These practices aim to be optimize plant nutrition, reduce cost of cultivation, enhance soil organic carbon, restore soil health, and prevent land degradation and soil erosion. Soil organism also play a very vital role. Here, the soil organism, I would like to say something that it is very important. They work for a while time, and we should utilize their potential in soil microbe. After that, they complete their life cycle. then we have to wait for a condition that they should work. Also play a very vital role in the nutrient cycle and biological fertility of the soil. There are better understanding of soil microbiology in essential for maintaining soil fertility, enhancing production in agriculture. So here are the great people have given some quotations for soil, and we should consider it. Science without humanity, knowledge without characters. This was said by our father of the nation, Mahatma Gandhi. Next is, yesterday is not ours to recover, but tomorrow is ours to win or lose. This is given by Johnson, and so on. The things goes on, and then in hell there is no other punishment than to begin over and over again to tasks left unfinished in our life. Edgar died, and those who believe to righteous good deeds, they are dwellers or of paradise, dwellers of paradise. Just think, they will dwell therein forever. Surah Al-Baqarah. This is from Quran. So these are the quotations which we have given. You can go through it, but they are very valuable. In Bible also there, in Vedas, the things have been given, and everybody knows about it. So soil is our key. I call Mother Earth, and without soil, nothing can be done. We can't feed our population, our country on a controlled condition, say such as greenhouse, white house, whatever you want to call. So controlled condition cannot be developed to the farmers. Farmer field we have to go. Agriculture means 70% of our agriculture takes place, whether you talk about the students, whether you talk about the university, whether you talk about the scientists, we have to go to the farmers to get the people aware. So this is my humble request. Take and give whatever you want to give to the earth so that it can become a good high real production country. Thank you very much. May God bless you, and I bless all the organization, all your organization, and you people, the organizers, those who have given a platform to us to speak around. Thank you very much. May God bless you.
Thank you, Dr. Alfred David, for you have equipped all of us with a great wealth of knowledge about soils and nutrient management. You have perhaps shown us the need of action on building today's knowledge for a sustainable future. Thank you, sir. It was a very wonderful presentation. On behalf of the team SAHAS and all the participants, I cordially thank you, sir. Thank you very much for your presentation, sir. Now over to you, participants. If there are any questions, please post up in the chat box. Participants, if you have any question, please post up in the chat box. So there is one question from Gurumukh Sodhi.
Yes, please.
Can nano urea be a future?
Nano urea?
Yes.
Can be a future?
Yes. What is the future of nano urea as in? Yes.
It is, nano urea has given up a good response, not for the high yield production, but overall it is good. But it should be in a controlled condition. It is performing well, but when we talk about the farmers, they are not getting the things as they used to get, because they are not so much so distinct, trained enough to use nano urea. Now, nano urea and many urea coated fertilizers are coming up, but they are not responding so well because of the knowledge or lack of knowledge, you can say, to the farmers. So it has initially it has been started. The things will be revealed, changes will come, and in future it has a scope.
Okay. Any other questions?
Bhushan, Mr. Bhushan,
Yes, sir.
are you there?
Yes, sir. Yes, sir.
So nice. Can you show your this thing? Can you video?
Yes,
Bhushan?
sir. So it was nice presentation.
Thank you. Uh,
Sir, there
thank
is
you
one.
very much. Yes, yes.
How can we
Yes.
avoid the nutrient loss? The question is from Dr. Aman.
How can we
Avoid the
avoid?
losses.
It is very difficult. As I have shown you the slide, only 30 to 40% of the this thing composition of the nutrient is used, otherwise it goes off. So it is harming the this thing, yield. Losses can be controlled in field by applying many methods. Like we should not throw the things or waters, and taking care once everything has to be considered so that the things can do good. As I have said in my this thing, that nutrient cannot be lost if it is given in time. When the things are required, when we feel hungry, we take food and we get nutrition diet. So as plants also require. Time to time, we have to take care. Whether you talk about soil, from where they take iron, cations, everything, soil solution, we should have a knowledge of that. Any more questions?
Thank you, sir. Any other questions?
Yeah. Anyone else?
No, sir. Perhaps there are no questions.
No, the students should come. They should put the questions. Question
Yes,
is very good.
there is one more
Question
question
hour. Yes, please come.
from Anil Kumar. STCR concept.
STR concept.
STCR concept. STCR.
STCR.
Yes, sir.
Soil
Exactly.
test crop response. So for this, we have to know about the condition of the soil. We have to know about the environment. We should know about the what are the crop required. We talk about from the as you have said about the training of the this thing, your training program, that when it is required soil this thing. So soil testing is a rapid chemical analysis. Here, chemical analysis access available nutrient status of the soil and includes interpretation, evaluation. As I have covered, we should know how to evaluate the things regarding to the properties. Whether you talk about physical, chemical, biological, weather condition for the crops, for the soil, everything we should know about. Many parameters come, and unless and until we judge from the parameters, then only we can go through with this soil testing crops. Every individual soil cannot grow rice, wheat, whatever your problematic soils are there. So many types of soil test crops should be required. That what type of crop we should take, when to take, how much to take, and what are their requirements. So it depends. Unless and until we have a soil test report. So the
So the next-
recommendations comes then only we can do. Any
Okay.
more things?
So the next question is from Ardeshwar. Applied nutrients, how much amount actually absorbed by soil and plants, and how much gets lost through evaporation?
See, it depends upon the condition of the soil, the people managing the soil. If we know how to manage this, then only we can save our soil and the nutrient. The loss of the nutrient take place through many sources, many factors. Sometimes we can control, sometimes it is uncontrolled. So this kind of things we have to go through.
The next question is, sir, what are the uses of nano urea?
What are the uses of nano urea?
Yes.
Nano urea works as a growth promoter to the crops. It promotes the yield of the crop, and we should know appropriate methods for applying the nano urea so that we can do good. The crop yield should be good, and high crop yields, as I have told, increase income farmer. So all these things can come if we know the proper way to use nano urea. And the concept has been developed by the IFCO. IFCO, we have in Allahabad, we have a full put IFCO. It produces the fertilizers, the nitrogen, and many others these things. So a big factory we have over here, production factory. So they have their different units. I'm going to take my student over there. So nano urea, we are getting up. It is not the farmer doesn't know about nano urea, much about it. Anyone else?
Other question is, how to convert unfertilized land to a fertile land?
Unfertilized. This can be done when you have an appropriate knowledge of soil, analysis report, recommendation, interpretation, and then only we can go through unfertile to the fertile soil. Suppose we talk about degraded land, suppose we talk about the problematic soils, suppose you take saline sodic soil over here in UP, it is too much is there. So we have to analyze each and everything. And the saline sodic soil has a problem of soluble salt, calcium, magnesium, and sodium. Sodium is the culprit ion which it carries. So we have to maintain. We have to take the before and after crop. We have to analyze the soil. Sometimes we take more this thing, and soil amendment we want to talk here. The soil amendment and the things are required: organic approach, inorganic approach, amendments, biofertilizers, all these things. Then only if there is a proper management known by the farmers, known by the scientists, then we can get unfertilized soil to fertilize.
Okay.
We have to manage, we have to go through.
Okay.
Thank
So
you very much. May God bless you again. I'm talking about and
Sir, there are a
privilege.
few questions more.
Now, one of my associate scientist will talk to you and he will tell. And if you have more this kind of thing you want to go through, then I can talk to you.
Yeah, sure, sir.
Okay, sir. Okay.
Don't mind it.
No, sir.
If Sunil want to ask anything, I can answer.
No issue, sir. The other sir can deliver his speech or he
Yes,
can
yes.
attend.
Dr. Reddy is here. You can talk to
Yes.
Dr. Reddy, and he's from Andhra Pradesh.
Samana, please welcome.
Yes, yes, please.
So, thank you very much, sir. On behalf of Team SAHAS, I thank Dr. Arun, Alfred, David for giving us the wonderful presentation and for enlightening us a lot about soil and nutrients. Thank you, sir.
Okay.
Now,
So,
I would welcome his I would welcome one of the doctors associate working who is under Dr. Arun Alfred David to address all of the student quiz. Over to you, sir, please.
Yeah. Good afternoon, everyone.
Good afternoon, sir.
My name is Ishka Srinath Reddy. So regarding the Arun Alpha David, sir, so I'm going to address any questions from the any other students or someone other else.
Sir, I would read out the questions now.
Yeah, of course.
How fertigation helps in nutrient cycling?
So how fertigation
Helps in nutrient cycling.
nutrient cycling. So
Yes.
basically, we will apply the fertilizers by the by the some of both basal dosages, some are by the foliar applications. So this fertigation is a one of the method. We can apply the nutrients by the with water or drip irrigation. So these how this it will help means the nutrient cycle is a process just encompass the movement of nitrogen from the physical environment to living organisms back to the environment. Okay, so these nutrients are present which are present in the earth surface, what are the in the soil that can be goes to the direct to the plant when the directly because when you apply to the broadcasting whatever the thing foliar space, they are most of the nutrients are which are getting be leached out. So majorly that is a big problem. So when through these fertigations, we directly providing the these fertilizers to the direct to the plant root zone over there. So when we are applying the specified the nutrient amount of fertilizers is directly uptaken by the roots and develop the production, whether it will be increase in the crop or it will be increase in the soil fertility status.
Okay. Thank you, sir. So the next question is from Dr. Rajan Kamboj. What are some
Yes, sir.
common nutrient deficiencies observed in Indian agricultural soils and how can they be addressed?
So basically, when you talk about the Indian agriculture soil, so the first and first more nutrient is we have the deficiency major amount of these NPK fertilizers. So that is why we are applying the so much of large quantity of these amount of fertilizers, right? So when we talk about the specified fertilizer, the our Indian soil has a more amount of loss of or maybe deficiency of these nitrogen fertilizers. How we can specify it? So majorly what the farmers today's present scenario, what the farmers are doing is so they are applying the without knowledge or proper knowledge of these. So what are the parameters for we can take nitrogen, phosphorus and potassium. They are applying the multi amount of nutrient fertilizer. So what are getting, what will happen to this is they are getting the chemical reaction when there excess amount of these chemical fertilizers. So what they have, it is getting to the inorganic form. It is not getting to the organic form. So how we have to manage these deficiency of fertilizers? There is a specific amount of that is only we have talked about the STCR, soil test crop grow response and integrated nutrient management over there and site specific nutrient management over there. So what we have to do? We have to know about the crop knowledge, crop physiology of the crop, where what is the amount of the crop we can provide at particular time. So when you talk about the majorly crop, it is a seedling stage or it is in a vegetative stage when it is a reproductive stage. So for that particular amount, when we don't know about the how much nutrient it can take, what is the physiology of the plant, so how we can know about it. So at that time we can apply that particular amount of the new fertilizers, that specified amount. So when you know all this amount of data, how much nitrogen is present, how much nutrients are present in the soil through the soil health card or some other data, so we can apply the specified nutrient which are required by the plant.
Okay, thank you, sir. So the next question is why Indian soil has low nitrogen and phosphorus content when compared to the soils of other countries?
So basically, when the nitrogen is affected by the majorly, it is organic carbon. So when you talk about the our olden days and ancestors, when there is when you these chemical fertilizers which are evolved in our country before after 90s, then only it is implemented in the other countries from other countries or it is getting manufactured over there. So before that, in our ancestors, whatever the before 18th centuries, what they have, and they are using our natural resources which are available like cow dung, green manures. So what they will do, these all the organic fertilizers which are giving the less amount of requirement of fertilizers. At the time, what they have to, the people are getting they are not getting that much of yield and expected yield for feed to the our nation, which are increasing the large amount of population. So after 90s, the emerging of these new fertilizers, which is a mixture of they have the less concentration and they have the high amount of nutrient content status. Okay, so when they are using these kind of fertilizers, so what they have to do, the people are getting the, when you are seeing these results of these chemical fertilizers which are coming to the India and manufactured in India, so they are providing a huge amount of nutrients to that. So when they're giving the amount of huge amount of nutrient, the crop getting more amount of yield and they are getting the more profit over there. So what will happen when then it is continuously following. They are, any of them are not educating, but they are one of the only my they are following is we have to apply the nutrients, then only we have to get the yield more. So what will happen then when there is a excess amount of fertilizer which is adding that, where it is losing its soil fertility status. So majorly the soil fertility can be depend on the soil fertility and soil health status. Then only it can precise the nutrient nitrogen content or phosphorus content. So what these other countries are doing, they are educating the farmers and they are reducing from the chemical fertilizers or origin is from other countries only. But now they what they are doing, they are completely converted into the organic farming. They know the value of the soil fertility, how they can be converted. So that is the reason why it is getting the, we have to educate our farmers by knowing. So do for in specific night nutrient farming, what are the requirement of nutrients that only we can add it, and then what are the which time of application we can do it, and majorly providing the sum of knowledge about how the crop can be grown, how the when the what is the time to apply the fertilizers, and what are the fertilizers we can apply. So what are the majorly requirement of fertilizers, and precisely and convert into the them, it is like precision agriculture. When you talk about the mixture of all the components over there, so when we mixture of all the, when we are using the technology, when you are using the same of high modeling technologies over there and analyzing where we are testing for soil health. So when you are mixturing these all the conditions, we can recommend them, we guide them with the help of this using of this organic fertilizer to increase this soil fertility. So next.
So the next question is how to manage calcareous soil.
So how to manage it?
Calcareous soils.
Calcareous soils. So the majorly the calcareous soil, basically one of the big problem of this calcareous soil, they have a less amount of organic matter content. The lack of, when there is a no lack of organic matter content, there is a lack of oxygen also. So when these nitrogen fertilizers may be applied at particular time, when the plantation before or after, when it is a vegetative stage or by the reproductive stage or flowering stage, at specified time when you apply these nitrogen fertilizer, so then it will be can be reduced that this we can manage the calcareous soil.
Okay.
Either some of the we have the around 10 basically we will talk about the only basal application and top dressing and foliar spray. Not only this method of fertilizer application, there are side spot application, side application, trench application. So when localized application, we have the management practices when you apply these fertilizers. So then we can follow the to manage the calcareous soil.
Okay. So the next question is what is meant by soil amelioration?
So sorry.
What is meant by soil amelioration?
So what is soil meant by soil amelioration? It is a basically thing about that organic and inorganic chemical of the soil, the conducting product applied to the enhance. So what we are doing is here, we are merging the inorganic and organic chemical condition of the soil to increase our crop productivity. So like we can say it either in the terms of soil productivity, and we can say it as a crop productivity for proper maintain of plant health. So that is we are integrate, like we can call it as a integrated nutrient management. We can say we are using their over there inorganic fertilizer, and we are using their organic fertilizers. So we are using the both of the terms of fertilizers while to make it the plant as so much of healthy.
Okay. So the next question is, why arid soil are basic? Please explain. The question is from Soumya Tripathi.
Can you repeat again?
Why arid soils are basic
Hello?
in nature?
Hello?
Hello, sir.
I am not getting your voice. 1 minute.
Why arid soils are
Hello?
basic? Hello?
Hello?
Sir, is my voice audible?
Yeah, 1 minute. Yeah, tell me.
Why arid soils are basic? Please explain.
Okay. So why the question is why arid soil are basic in nature? It is almost predominant, which is comes under these arid soils or comes under the soil order, which can say it as a desert soils. So it is majorly found in the these Haryana region and Western Rajasthan, Punjab, and some of the parts of these regions over there. So what is the there is the alkalinity of the soil will be the more when the pH of the these arid soils over there should be high more than 8. So more than 8 we can consider as these arid soils. So and some more things we can say it as they have a humid region. So are acidic or so. As a result, we will lose the leaching of some of the basic elements. So when we are losing some of the basic elements, like we can say it as a SHU oxides or aluminum oxides. So when the leaching of these excess amount of these SHU oxide or LK oxide, they are losing the calcium and magnesium potassium content, then it is converted into the basic nature or alkaline nature of the soil.
Okay. So the next question is, what are all the organic fertilizers or pesticides that we can use in the place of inorganic fertilizers?
So what are all the organic fertilizer? Basically, when I saying to the organic fertilizer, there is a classification of fertilizer we have going to study. We are already studying some of the so many days in agriculture. Basically, only one fertilizer which are used as an organic fertilizer. We can say it as a urea. So basically, this urea has made it from the carboxyl group. So when you talk about the preparation of the fertilizer, it can be prepared from the when we can talk it about as a organic based fertilizers or inorganic based fertilizers. So when you talk about the organic based fertilizers, so only comes under it is made up from the carbon group. And when you talk about the inorganic fertilizers, so it is made up from the carbonates and bicarbonates and oxides and cyanides and some of the oxides also. So here, when you talk about this organic made up of fertilizer, only the urea which is made up from the carboxyl group, which has the content of carbon. Okay, so when it has a content of carbon, then only we can estimate as this urea has a organic group. And when you talk about these inorganic fertilizers, so these which are made up from the SHU oxides, some bicarbonates and carbonates. So we can use it as these fertilizers are made up from the inorganic fertilizers. So when we have to use this organic, basically we are applying basically as some of example I can give how we can use these fertilizer is. So every time when the pest is affected, right, it is loss about the sum of nutrient. The plant lost its vegetative growth, right? The pest will be affected, the plant won't grow properly. So what we will do when when you are applying any pesticides, we can mix about 10% of urea into the what are the spraying or pesticides over there. So it will give the better yield because the plant already lost its wastage. The pesticides, all what are the insecticides are already taken as good as the amount of vegetative growth of the plant. So when the urea is major work of the urea is the component of urea is to develop the vegetative growth of the plant. So when you mix these urea and with pesticides means it will provide nutrient to sources for the plant also, and it will give the regenerative growth of the plant.
Okay. So there is one more question. Where subsoil hard pan is found?
Where?
Where subsoil hard pan is found?
Where subsoil hard pan is found, it is below the uppermost topsoil layer.
Okay, okay.
So we have the category of like soil. When you talk about the soil profile, there will be A zone, B zone, and C zone, and regolith. So when you talk about there is a two difference of the soil. We have the profile. When you talk about the forest region soil, it has an organic zone, so which has a content of more amount of 18% of organic carbon in that soil. But when you talk about the normal land, when you are seeing over there, we have the only started from the A origin, B origin, C origin, which is the A origin is the topmost soil where the all these nutrients are present over there. So below the topmost layer, the soil hot pan is present. So any more doubts?
This was the question and answer session. Any other questions? Participants, if you have any other questions, please post up in the chat box. Guess there are no other questions. So thank you, Dr. Srinath, for wonderfully answering all the queries and addressing all the queries of these candidates. You have addressed it very well and you have explained all of the queries very well. Thank you, sir.
Yeah, thank you so much. Thank you so much for cooperating on all those things and organizing the meeting and everything by presentation, and the host for the hosting team and presenting team and organizing team. So I would like to congrats and thank. So I would like to emphasize this some more in the future also. So if anyone requires this kind of PPTs, I will share with the organizing team or hosting team. So I will share the PPTs if anyone requires this PPT. So if anyone has any doubts, you can contact me, as I will provide some email ID and mobile number. So any have these doubts in the between the soil and presentation, you can simply contact us.
Okay, sir. On behalf of the team SAHAS, I extend my heartfelt thanks to you, Dr. Srinath, sir. Thank you very much.
Thank you so much.
Thank you, sir. Thank you. So, dear participants, we are almost towards the end of our training session. Tomorrow we'll have one more training session. So I request all the participants to join as soon as possible and make the best utilization of it. And there will be a feedback form that will be provided towards the end of this training session, which you all need to fill up and submit in order to get the certificates. So it's a request to make better utilization of it and equip yourselves with the great pursuit of knowledge. So looking forward for future endeavors. With this, I'll take your leave for today. Thank you.